Hello, so this is my presentation for Data 607 Fall 2020 semester. I chose to do the topic of data science in financial institutions, which I felt was of much interest to me because I currently work in Ridgewood Savings Bank. I have been network administrator for 2 years now, since 2018. And I was always curious, not only on the technological side of things. I primarily work with routers, switches, virtual machines, physical equipment, but I've always been interested in the fraud analysis, financial analysis aspect of the bank and how this works. One key background information I would like to convey is regarding fraud report statistics. And if we talk about this, we cannot forget to mention the Federal Trade Commission. They have a mission of protecting consumers and competition by preventing anti-competitive, deceptive, and unfair business practices through law enforcement, advocacy, and education without burdening legitimate business activity. So here, a core part of the FTC's mission is to return money to the consumers who are harmed by illegal business practices. And it's a curious fact that over the last 4 years, consumers have cashed more than 1 billion in FTC refund checks. Another important point of information to mention is Federal Trade Commission fraud reporting statistics categories. There are three top major categories in which the major cases fall. Number one being identity theft, number two, imposter scams, number three, telephone and mobile services. In total, about 3.2 million reports were shown. This is from 2019 data. There has been 1.7 million fraud reports out of those total reports. This resulted in a 23% reported loss, estimated 1.9 billion total fraud losses, and the median $320. One of the most interesting facts within researching this topic of fraud and how it pertains to data analysis is that, in fact, younger people reported losing money to fraud more often than older people. So we see here about a 33% of users aged 20 through 29, and in fact, only a 13% of users aged 70 through 79. But of course, when people age 70 plus had a loss, the median loss was much higher. Many experts relate this information and compare it to the technology of nowadays. Many youths are now paying over digital services, phones, computers, laptops, which is more prone to fraud, I would say, nowadays. Now we can say for the past several years regarding fraud detection and machine learning, the techniques have been heavily rule-based when it comes to how institutions handle fraud detection. When it is rule-based, we can say it is often insufficient, oftentimes relies on human endurance for results. Um, this has to do with intuition as well, depending on each person investigator. And obviously, the human response time may be slower when compared to newer machine learning approaches of today. Financial criminals as well are very intelligent and they are constantly evolving to stay one step ahead of the game. So we can say that in certain rule-based approaches to fraud detection, which we will see in the next slides, may be considered outdated or not necessary. Many fraudulent users now adapt. They learn the rule-based systems of today, potentially even by hacking or compromising into the systems of the financial institutions. And this way they're able to create newer, more clever techniques to evade the system. It is without a doubt that there is now challenges nowadays with the whole digital transformation. Many financial institutions have been becoming increasingly digital as far as apps and computer programs. This is very convenient from a user perspective. However, it creates huge vulnerability. This also creates many access points for the criminals or fraudulent users to perform their fraud activities, as well as new account frauds and mobile phone account takeovers have become increasingly popular for fraud users. Now, of course, with any type of approach, there will be false positives. On average, 90% of alerts are false positives. Analysts become numb to these false positives, which sometimes create a bad image for the company if many false positives are acted upon. And machine learning can help to pick up these patterns and return a sort of risk ranked backed system alert process, which you can say is priority based. And this makes much more sense to do things this way. I can relate this to technology. In the bank, we have a help desk system, which is also priority based depending on the alerts and depending on the tickets. So our ServiceNow system is similar to this in the case that if there are many type of similar alerts, it kind of creates a correlation and lowers the priority if it feels strategically that it is a false positive. Now, many people will ask, is there a magic solution to this rule-based old approach to fraud detection, fraud analysis? And the answer is without a doubt no. Fraudulent crimes will always exist, no matter what type of system is created or out there currently. The most important things humans need to realize is a trade-off, which in this case is augmented intelligence. You have to incorporate machine learning with traditional rules-based systems. This is the best approach for catching fraud more accurately and in real time. Just to take a step back, I would like to include from the earlier weeks of Data 607, where we had a reading from Geoff Colvin for discussion board. And one quote that I really liked was, they'll take the cognitive work, but not the interaction jobs. And he rejects the nightmare future scenario of jobless humans supplanted by brilliant all-purpose machines. The point he is trying to make here is that technology is not a cause to be scared for in the future. If technology and humans can come together to create a more creative solution and approach, which will always be evolving. Next, I would like to discuss briefly some terms that I felt important regarding anomaly detection. And this is, of course, a process by which deviations from expected behavior, or in other words, the norm, are discovered. Number one, we have point anomaly, which is a single data point that is anomalous in all situations. Number two, we have contextual anomaly, a single data point that is anomalous under certain conditions. And lastly, number three, collective anomaly, which is a collection of different data points are anomalous when occurring together. I will have a few description example in the next slides as well. From the previous slides, you may be curious or asking yourself what the terms meant or if there's any examples to make things clear. And in this slide, we have examples number one of point anomaly, which is, for example, $100 million transaction on a bank account or credit card. This may be considered point anomaly for your average person. Number two, a conditional anomaly is, for example, a transaction attempt much higher than the credit limit of a person or institution. And number three, collective anomaly, which is, for example, ATM transactions occurring in two countries simultaneously and oftentimes multiple times. So next I wanted to touch upon a term that I felt is most interesting to me personally. Now, at Ridgewood Savings Bank, where I'm currently employed, every employee, no matter what department that person is in, must go through a small training and a test. This basically confirms the knowledge from all employees regarding the bank and institutions, regulations, fraud activity, plans, and within this we have the suspicious activity report, which is known as SAR, and many financial institutions detect these suspicious transactions many ways. For example, financial institutions will receive some sort of suspicious document or transaction, and then it is the obligation of the financial institution to analyze and also assess in order to create a report to submit to the appropriate authorities. This is according to compliance regulations. With this activity, it helps to prevent potential criminal behavior, money laundering, and financing of terrorism. You may ask when and how this occurs. Well, for example, bank potentially suspects transaction from one of its clients is fraudulent or harmful. So these transactions have a certain value to them. For example, international money transfers or unusual transactions or activities on an account. And another type of activity that is harmful, computer systems which are hacked or compromised in any way. Now, this is detected by an institution's automated monitoring system. However, it also falls on the human administrators to verify and report that bad activity. So here, once again, we see that collaboration between the human aspect and the machine learning technology side of things. Here we arrive to the slide on transaction rules, which we were speaking of earlier, the rule-based approach. And the program, it has certain conditions. For example, if a purchase is made in specific location or over a certain threshold, then the system labels it as fraud. Also, the result of this process is often called binary labeling. And we see that it's extremely high occurrence of false positives from this type of system. And you'll often see it may cause customer discontent, as oftentimes legitimate transactions may be flagged or marked as inappropriate when in fact they are legitimate. So in this case, there is a need to invest time and money in manually reviewing and training to use this system. I took upon myself some time to research rule-based approach as it pertains to data science and Python programming. And here we have, for example, a basic program which tries to detect that fraud. We have a traditional fraud detection function. We insert the user purchase transaction data or data set, and we put conditions to it to return if it is or not fraudulent. In this case, if the purchase location is Zuck's office and the purchase amount is greater than 1,000, it will return false. If this is not the case, it will return true. Now here on this slide, we see a modern approach or modern scenarios that were not available or not occurring in the past. And machine learning AI approach is, for example, designing and applying algorithms that are able to learn from the past. You'll see that AI detects and recognizes thousands of patterns of a user transaction history profile. This is instead of only the few captured from the rule-based systems. AI also facilitates analyzing non-common fraud patterns, such as time spent on the screen or to detect touch. You'll notice I've included an example here of a function that is written to detect this type of behavior. So using some techniques of JavaScript, for example, on a web page where you collect device level data, you collect behavior of the person visiting the page, and then compare what they usually do, for example, tapping on specific sections of the page or when using a mobile device. This comes extremely handy when taking all of the information and putting it together to create a better resolution, better analysis, and once again, cutting in half those false positives that we saw from the previous slides, which negatively affect the organization. So here on this slide, you'll notice some information previously seen in the lectures and textbook from Data 607 and from the Bridge program as well. This basically describes the gathering and segmenting of the quality transaction data. In other words, the process to create a model to predict the probability of a transaction being fraudulent. We see here first, in the first phase, we have identifying and acquiring the data, which entails many type of files such as CSV, JSON, use of API, streaming, text, and HTML. This falls particularly often on data managing teams and the legal compliance departments. In number two, you will see the process of storing, structure, and pre-process of the data. This entails familiar terms such as Apache Spark, Amazon Cloud, and SQL to perform these tasks. You'll often see software, system, and data engineers handling this aspect of the process. Number three, you'll notice we have analyzing of the data via machine learning, design signals, backtest strategies, which is more related to what we are studying and what this degree is preparing us for. In this case, we see the use of R and Python programming, as well as Spark ML, Tableau, Excel, and these tasks are performed by data scientists, quantitative researchers, and PMs. Lastly, you'll see in certain institutions, you'll have a section where it's trade ideas, trading signals, risk analysis, and this generally falls, it is created by reports, alerts, and signals which are analyzed, and you'll oftentimes see this job function under the umbrella of the traders, PMs again, and execution systems. So just to recap, we have seen some information in the previous slides as it pertains to steps leading up to building a model for prediction, for fraud detection, and what departments and programs play a key part in this. You'll be asking yourself now, what happens after building the model and what kind of prediction problem is used? In the next slides, we will review supervised classification, and this entails classification problem versus logistic regression discussion. In this slide, we will be discussing what is known as a classification problem, and this is used when trying to classify a transaction. You'll oftentimes see this relates to decision tree approach. This is again a supervised learning technique. It entails a set of rules that are trained or updated using examples of fraud that clients face, and it ignores non-chosen or irrelevant features as well. Once again, this type of scenario requires or can be inspected visually. Oftentimes, as a result of this, it is given a probability score. I researched and found the library used in Python to perform this type of analysis. It's called sklearn or also scikit-learn. And you'll see from the slide graphic that it takes in a value and it determines the ranking based on certain features or certain conditions. For example, if the amount in this case is greater than $20, it will check to see the country from which the card was being used, and if it is in fact a certain type of country, example Canada, it will return a 100% value, as opposed to if it is not from this country, then that type of transaction will receive a 50%. Also, example, if the amount was less than $20, the countries the card was used from is greater than 2, it will return 100%, and if no, it will return 25%. On the other hand, we also want to see and discuss logistic regression. This is considered an alternate model. Now you'll notice it doesn't try to predict the value of a numeric variable given a set of inputs. In fact, the output is a probability that the given input point belongs to in a certain class. You'll see this measures the strength of cause and effect relationships in structured data sets. It is done by assessing the predictive power of individual variables or a combination of those variables. And you'll see that, of course, this is all part of a larger fraud strategy. Also notice the authentic transactions are compared with the fraudulent ones, and this is what helps to create the algorithm. Then this is used to predict if it is fraud or not. You'll see here in the slide graphic, we have on the y-axis label probability of fraud, labeled from 0 upwards, and on the x-axis the features, for example, trans amount, type of store, time, location of the last transaction, and if it falls under this curve, it is not fraud. If it falls above, it is fraud. Now, prior to concluding this presentation, it is very important to also discuss the other side, which is unsupervised anomaly detection. In the previous slides, we saw supervised classification systems, which entails a ranking system or a labeling type system. This is not the case here. When you talk about unsupervised detection, you'll see that it draws inferences from datasets without labels, and it is best used if you want to find patterns but don't know exactly what you're looking for. And the objective of unsupervised anomaly detection is to detect previously unseen rare objects or events without any prior knowledge about these. The only information available is that the percentage of anomalies in the data set is small, so usually less than 1%. In general, I'd like to describe this approach as having minimal information or minimal prior scenarios. You'll see from the graphic, this is displayed in inputting raw data. Then there's a system of interpretation, which is passed into an algorithm where it is processed, and then it outputs the result based on the specific type of algorithm being used. So in conclusion to my presentation on fraud detection and fraud analysis as it pertains to machine learning, I just wanted to go back and reiterate a point. No matter the type of classification process used, supervised, unsupervised, it is without a doubt vital that the human element as well as the technology side of things, which creates augmented intelligence, move forward in this process. One is not better than the other. In combination of both is how strategies are created and formed and new forms of fraud detection are improved. From discussion board number 4, I also wanted to quote from the Dan and Chip Health article 2010, which states there is always a bright spot. This phrase has stuck out to me out of most from the discussion boards, and it talks about there is always a solution no matter the problem. And here we see when humans are having an issue with the fraud detection side, we use techniques from machine learning, such as algorithms and detection processes created to do a combination and solve as best possible. No problem is too difficult. Any problem can be tackled piece by piece with patience, and there is always a solution. Thank you very much.